All right, we are going to work on our spring final review, which looks like this. And I'm going to start with the first 8 problems, and that would be standard 12.0, which is simplify rational expressions by factoring. And our rational expressions, once again, they're fractions. And these fractions have polynomials in the numerator and the denominator. So we have to know how to factor polynomials to do this. So number 1 looks like this. And if you'll notice, there are no addition or subtraction signs in these terms. So this is one term, and this is one term. The only thing going on here is multiplication, no addition or subtraction. So this is a monomial. This is a monomial. It's one term. They aren't terms being separated by addition and subtraction signs. This is just one term by itself. Well, when it's a monomial, we can just factor it by breaking it apart. So I just factored both of those monomials, and every single one of these is a factor because these are all being multiplied, no addition or subtraction. So I can just cancel out common factors, and I'm left with an a in the numerator and 3b in the denominator. I have one a left over, a 3, and a b left over, and that's as simple as it is. Number 2. 3x plus 12 over 6x. Now, this is not a monomial, it's a binomial because there are 2 terms and they're separated by an addition sign. So I cannot just break this apart like I did the monomials. When it's a polynomial, I have to use my menu. My menu is look for a GCF, look for special cases. My special cases are perfect square trinomial and dots. Then I'm going to look at a, and if a equals 1, I'm going to do x-man. And if a does not equal 1, I'm going to do extra x-man, which means I do x-man and then I do the Punnett square and look for my GCFs. Well, start at the beginning. This is a polynomial. I'm going to go to my menu. Is there a greatest common factor? There is. I can pull a 3 out of here and a 3 out of here. So I'm going to take out that 3, and what's left is x plus 4. Because if I do my distributive property, I get 3x and I get 12, positive 12. And I know that that's the largest factor because x and 4 don't have any factors in common. So 3 is the largest factor that these 2 terms in this binomial share. And in my denominator, I have 6x. This is a monomial. It's one term. I can just break that apart. So in my numerator, I have 2 factors. 3 is a factor, and x plus 4 is a factor. In my denominator, 3 is a factor, 2 is a factor, x is a factor. Are any of my factors the same? Yes, they are. That's it. X plus 4, we call this a package deal. It's a binomial factor. This whole thing is one factor, and what's left in my denominator is 2x. I cannot cancel out this x with this x because this x is not a factor by itself. It's part of this binomial factor. Number 3, 5x squared minus 10x over 3x squared minus 6x. See this subtraction sign? 2 terms, binomial. This subtraction sign tells me I have 2 terms, binomial. I factor polynomials using my menu. So I'm going to look for a GCF. In this, I see that 5 and 10 share a factor of 5, and what's the most x's I can pull out of both of these? I believe it's 1x. So 5x times what equals 5x squared? That would be another x. And 5x times what equals negative 10x? That would be negative 2. Let's double check that. 5x squared, yep. Negative 10x, yep. This is factored. After I pull out my GCF, this is not a special case, and it's not a trinomial, so I'm not going to use X-man or extra X-man. So this is completely factored. In my denominator, I see a GCF of 3x. And after I pull out my GCF of 3x, I see I have an x minus 2. 3x squared, check. Negative 6x, check. Now, look at this. This is a factor, a binomial factor. This is a binomial factor. They're exactly the same. But check this out. Now what I'm left with is a monomial in my numerator and a monomial in my denominator. Well, monomials can just be, as we say, busted apart or sliced and diced. And when I do that, I can cancel out my x's and I'm left with 5/3. Number 4. X squared minus 16 over x squared minus 6x plus 8. All right. Binomial, polynomial, menu. No GCF, but this is a special case. This is dots. It's the difference of two square terms. Well, the way I factor dots is SAD, and SAD stands for sum and difference. Sum of what? Square root of this is x, goes here and here. Square root of 16 is 4, that goes here and here. If I multiply these two polynomials together using a Punnett square, I'm going to get x squared minus 16. Polynomial, menu, no GCF. It's not a PST. It's not the difference of two squares. I'm going to try X-man because the leading coefficient is 1. 1 times 8 is 8. Negative 6 is my B term. Let's see. It looks like, I know 4 times 2 is 8, but this is going to be negative. So when I combine these, I have to get a negative 6. Well, if I do that, that's going to be negative 8. But what if I do this? This times this is positive 8, and this plus this is negative 6. So that's how I'm going to factor this. So I'm going to go x minus 4 and x minus 2. I have two factors in my numerator, two factors in my denominator. This factor and this factor are exactly alike, and I'm left with x plus 4 over x minus 2. I cannot cancel these x's because these x's are not factors. They're part of a bigger package deal binomial factor. Number 5, a squared plus 5a plus 6 over a squared minus 3a minus 10. All right, trinomial, it's a polynomial. I'm going to use my menu. There's no GCF. It's not a PST. It's not dots. I'm going to use X-man, and when I use my X-man, I know I'm going to get a plus 3 and a plus 2. And when I factor this, again, it's a polynomial. I'm going to use my menu. There's no GCF. It's not a PST. It's not dots. Leading coefficient is 1. If I use X-man, I get a minus 5 and a plus 2. Ha! Common factor, common factor. I'm left with a binomial in my numerator and a binomial in my denominator. This is a package deal, and this is a package deal. Number 6, 4c squared plus 32c plus 48 over 6c squared minus 24c minus 72. Yowza. Polynomial, going to factor with the menu. Polynomial, going to factor with the menu. GCF, let's see, 4, 32, and 48 all share a factor of 4. Can I pull a c out of all of these? Nope. 4 times what? Let's see, 4 times c squared is 4c squared. 4 times 8c is 32c. and 4 times 12 is 48. Let's finish factoring.